Dear students, welcome to the knowledge series. Today we are going to discuss on type 2 fuzzy set. Now in this new area in the fuzzy logic, the type 2 fuzzy set, it is basically the advancement from the type 1 fuzzy set. Now when we talk about a fuzzy set applications, the application was around for 40 years before a further development took place. You know that Dr. Latif Asghar Zadeh, way back in 1965, introduced the type 1 fuzzy set. Now fuzzy set, as the term indicates with respect to the figure which you can see over here, the right side figure is a crisp set form of a representation where you can see the sharp edges, and these sharp edges represent that either there will be a value related to the crisp set in the form of a true or false, yes or no, 1 or 0. So that is what we talk in the crisp set logic. But when we talk about a fuzzy set is nothing but a vagueness in the figure. There is the edges are not sharp, so that's why, because of the lousiness of the sharp edge, we cannot able to predict in the form how the crisp set used to determine. However, the fuzzy set has its advantage over the crisp set is that even if in this vagueness, it will able to predict the output, how much close that value should be in terms of the sharpness. So here if you try to see, fuzzy set and the crisp set are the part of the distinct set theory, where the fuzzy set implements infinite valued logic while crisp set employed a bivalued logic. So here it is a two-valued logic, and here it is a bivalued logic, infinite logic. More about the fuzzy set, you can refer to my earlier video series with respect to fuzzy and its sets. So let me again come back to the fuzzy set. Is that fuzzy set has its membership functions, which is ranging between 0 and 1, whereas in this crisp set it is 0 or 1. So the membership functions is basically user oriented, and its value varies user to user, like linguistic words. So that's how it changes. Because if you say temperature of a room, somebody will say mild, somebody will say that average, somebody will say that it is moderate. So these linguistic terms will change the variations in the membership functions. Now when we talk about a type 1 fuzzy set, and when you see across to this particular figure, here type 1 fuzzy set is being shown over here. So this is the representation of a type 1 fuzzy set. So in this particular triangular structures, you can try to see that x-axis is nothing but the crisp set values, and y-axis is nothing but a membership of functions with respect to the crisp set values, where this is a 0 and this peak is a 1. So this is the representation of a fuzzy set, and between this peak and between this 0 there is a slope. You can see this slope is having infinite sets of value which ranges between 0 and 1. Now type 1 fuzzy set is a word that is scientifically incorrect, because type 1 fuzzy set is having a certainty, because when you talk about a type 1 fuzzy set, it talks about a range it talks about what exactly happens at that particular instant of the elements. So that is how we can say that the type 1 fuzzy set to model a word is scientifically incorrect, because type 1 fuzzy set is talks about a certainty. For example, if a child learns learning capability, if you take different childs learn has a capability learning capabilities. Every child does not learn in an equal way. So under that conditions there is variations with respect to the child itself. So if you take a fuzzy like this particular situation, even if it is a certainty, but under the class of that type 1 fuzzy set, if the same applications will have a variance. Like I'm taking an example, child learning. The child learning varies if you are taking under the class of a type 1 fuzzy set. So if the child variations in the learning capability varies because of the same fuzzy set, then in that case, then type 1 fuzzy set will not be suitable. Under that condition, the type 1 fuzzy set has something else to add because of the uncertainty. Fortunately, most of the applications of a type 1 fuzzy set only use a mathematical model of such set and do not focus on the actual models. So that is the basic reasons. We consider that, okay, this is the model and that should be applicable to an application. But within the application there is a variations. So on that condition, under that situation or under that conditions, type 1 fuzzy set comes as a question mark. There are applications of a type 1 fuzzy set in which fuzzy systems is used for the approximate random data, and this model is unknown way with time. So that's the thing, is that this model remain unknown with respect to the time. But later on the development took place, and type 1 limitations the people started trying to find out. Even when we look across to the Latif-Askar-Zadeh, when Latif-Askar-Zadeh tried to develop this particular model, and way back in 1975, when Latif-Askar-Zadeh found that there are certain limitations with respect to the type 1 fuzzy set, then the type 2 fuzzy set they look across. But actually when we talk about a type 1 has a limited capability to directly handle the uncertainty. So that's the particularly we see across in the type 1. So this uncertainty limitations, when we talk about uncertainty, that means there is no certain that particular thing's occurrence will be there. That's why type 1 fuzzy set is a paradoxical. Paradoxical means inconsistent. We consider type 1 as a inconsistent or a paradoxals. And this paradox about the type 1 fuzzy set has been there for nearly 10 years. And Zadeh in 1975 already recognized that there is a problem in the type 1 fuzzy set. So it took nearly 10 years later he introduced a new fuzzy set which is putting under the put under the class of a type 2 fuzzy set, even a higher type. So when we talk about a type 2 fuzzy set, actually it is a generalized standard of a type 1 fuzzy set, where most of the uncertainty exists, and that uncertainty is being handled in the case of a type 2 fuzzy set. Because from the very beginning, the type 1 fuzzy set, there were a lot of criticisms about uncertainty, because with respect to the membership functions. How it has to handle and how this particular uncertainty has to deal with respect to membership. Professor Lothifas Karzadeh worked with the extension of his own research work, and thereby he developed a type 2 fuzzy set. And a type 2 fuzzy set, if you look across, it incorporates all the uncertainty about the membership functions with respect to the type 1 fuzzy set. And thereby, the criticism of the type 1 fuzzy set was tried to resolve under the case of a type 2 fuzzy set. And type 2 fuzzy set reduce the type 1 fuzzy set uncertainty to a large extent, and which is analogous to probability reducing the unpredictability or the uncertainty vagueness situations. So that's how the type 2 fuzzy set has been developed. Now when you look across the type 2 fuzzy set, the type 2 fuzzy set representations has something to speak about. Here we are seeing the single edge, whereas here you can see the rise and fall of the edges is having areas, whereas here that area is missing. So this area, it talks about the vagueness or the uncertainty situations. So symbolically, to distinguish between the type 1 and the type 2 fuzzy set, under this particular notations, say we define A on the top of it, we either symbolic representation, or on the bottom of it represents the fuzzy set. So under that particular condition, type 2 also we consider the same symbolic representations. However, but there is a representations with respect to the functional way. The type 2 fuzzy set, we find the difference with respect to the type 1 fuzzy set. Now since here you can see that there is a two variation, is that one fuzzy, the same fuzzy set representation with two slopes. Like this one, Dr. Zadeh, he started working with the logical progression from the type 1, type 2 up to type n-type fuzzy set. That means with the n ranging from 1 to like this one onwards. And today you can find that certain some of the researchers, they are even working on this higher level of the fuzzy set, which is still a wider scope for the research domain. Now if you come a little below, here you can try to see that type 1 and type 2 fuzzy set. In the type 1 fuzzy set, if you draw a line here, let us take this is at this particular set point. If you draw a vertical line, it intersects at this particular point. So when it intersects at this particular point, so you take a corresponding to that one, what is the membership value in the y-axis, so you will be getting a value. The same thing if you copy it across to the right side. That means you draw this figure, but with in the form of a type 2 fuzzy set, but you keep the same length, same vertical sections in such a way that maybe that this point will be intersecting the fuzzy 2 fuzzy sets on the right side. This will be intersecting on the right side slope on with the left section. So here you find that under the case of a type 1 fuzzy set, you get a one single point, whereas here you get a two different point under the same single situations. So this is the uncertainty that exists between the type 1 and type 2. Now, depending on the variation on the area, if there is a little variations in this particular green area, automatically what will happen, the two upper limit and the lower limit, it is definitely going to change. So in this particular situations, we have to look across that how this particular point we can able to deal. So with respect to this, Dr. Latif Zadeh, he worked about on the another set of representation, which you can see over here. That is a type 2 fuzzy set representations with respect to the figure which I have shown over here. This is, you can see from the net, this particular figure, but for your understanding, this has been taken for explanation. So in this particular figure, the membership function of a type 2 fuzzy set, where you can see this is one edge, this is another edge. That is what I mean to say. So under the type 2 fuzzy set, which if we take a fuzzy set F to represent this one, or then in that particular situation, then if you take a vertical line, you can find that there is a third dimensions is also existing from here. There is a third dimension. This is one dimensions with respect to the single dimension, is a two dimensional, where you have a one area here, and also you can try to see that there is an area which can exit to this side also, because here in a two-dimensional structure you can only see this surface, but what about the third surface? That also we have to take into account. So, so a cross sections of one slice of the third dimension that has been projected from here, and this projected site that is from a two-dimensional domain, that is called as a footprint of uncertainty. That is told as a footprint of a uncertainty. That is a third dimension value, is the value of the membership functions at each point of the two-dimensional domain. That is called as a footprint of the uncertainty, or FOU. That is what we termed it as. So here, under the footprint of the uncertainty, if it is existing on this particular case, so this boundary of the cross sections is used to describe the membership functions of a type 2 fuzzy set. And if you look across this particular type 2 fuzzy set, there is the third dimension normally is ignored, but only the footprint of the uncertainty, because this third dimension is sitting on the surface of the this area, or called as FOU. So we normally ignore this one, and we take into consideration this FOU to do the analysis further. So that's why the interval, this type 2 fuzzy set is sometimes called as a FOU model. So based on this FOU model, we can try to identify the second order uncertainty in the case of a fuzzy set model. So that is what we see how the Latif Zadeh tried to solve the type 1 fuzzy set uncertainty. Now if you go further with respect to the figure, now here in this figure you can see that this FOU, which is shown over here, this FOU for the type 2 fuzzy set interval, it varies with respect to the range. So that is what here you can see. Now this range is going to create a blurring effect. So that is what we try to say. Now here we are seeing the blurring, but this is with respect to type 1 effect is there, but that can still occurs from the type 2 fuzzy set. So that's why under these particular situations, so the blurring situations, blurring rise exist in the type 1 that can be taken into considerations under the type 2 fuzzy set, so that we can try to use the mathematical functions to find out how that particular blurring can be able to determine exactly in the case of a type 2. And now this type 2 fuzzy set, if you try to see further with respect to under the type 1 type 2 fuzzy set in the further figure, you can try to see that if a x1 is considered as a crisp set value and drawn vertically, it intersects at certain point where the membership value is determined by mu I suffix x. So that is what shown here. So based on this, you can plot the output in terms of a two-dimensional plot, where you can try to see that at point x1 you are getting a value 1. So that is what it means with respect to the figure 1. But on the other hand, if you the same figure, if you take to the other side, where here only one edge is touching, but the same type 2 fuzzy set, if you are taking a plot with respect to a crisp set value where the intersection is touching the two edges, then you will be having a two different value. One is a minimum value, another is a maximum value. So if that is the situation, so if you try to see the minimum value is, you are having a this is a if you are taking with respect to mu a, if you are taking, let us take that if it is x2, so I of x2 is here, so you are taking a mu min of ix2, mu max of ix2. So here you will get a mu minimum value, mu maximum value. So that's that will create a membership value, but the areas or the range in the case of x1 as compared to the x2 will be the x1 case will be based on the range between the point this to this. But if you draw this particular situations, that will be with respect to this dimension, if you are viewing from the other surface, you will be finding that it is only the small portions, whereas in this case it is a larger portion. So that's how these two fuzzy set is being shown. The work now here, before I conclude, work on the type 2 fuzzy set. I actually took a drastic space or the momentum increase from the 1975, even in the during the 1980s and or even in the 1990s, several articles were published under that particular period, and Zade even proposed the type 2 fuzzy set in 1976 itself, and this has changed later in 1995 as a result of Professor Jerry Mendel, where he did a work on the type 2 fuzzy set and its systems. So afterwards, more and more researchers around the world they started working on the area of the type 2 fuzzy set, and they even wrote several articles which you can see in the internet with respect to type 2 fuzzy set and the systems. So with this, I conclude here, and we will continue of the type 2 fuzzy set in the next session. Thank you.